Hello guys, welcome to another video. This one is paper 2-2 of May-June 2010 for Add Math. This one is also a requested question or paper from one of the subscribers. With that being said, let's move on to question number 1. Okay, so let's see what do we have here. So we have to integrate this expression. As you can see, we can first simplify or break this down into pieces. So what do I mean? I can rewrite this down as integration of 2 dx. We have plus, now we plus, integration of 5x, and then we have minus, so of course dx here, minus integration of, so here we can rewrite this as what? We can send this on top, it will be x minus 2 power minus 2 dx. Now this way it becomes very simple to solve one by one. So let's continue here. This will become 2x, obviously, right? Plus here 5x squared over 2. Here we have minus. This will become x minus 2. We have to add 1 to the power, becomes minus 1, divided by the power. Of course, plus c. And finally, you will have 2x plus 5 over 2 x squared plus 1 over x minus 2 plus c as your constant of integration. That is your question number 1. Now for question number 2, this one is a sets question, so you guys won't be having sets in your Add Math paper, so you guys don't have to worry about this one. We can just skip question number 2. Now for question number 3, we have what? The volume V of a spherical ball. Okay. Now first thing first, as you can see here, we are dealing with volume. And also the good thing is we have been given the formula already as well, which is volume is 4 over 3 pi r cubed. That is the good thing, right? Now, given that the radius is increasing at a constant rate of this, so which means whenever you have rate, it means related to time. So the radius is increasing at a rate of 1 over pi. So we're given this information. Okay? Now, we have to find the rate at which the volume is increasing when V is equal to this value. Okay, so let's see how can we do this. So first thing first, what are we trying to find? We are trying to find the rate at which the volume is increasing. So we are trying to find dV by dt. Right, now we have to form an equation to be able to solve this. If you observe, here we have this. It is by the chain rule. On top we have dV. We write dV. At the bottom we have dt, we write dt. Now they must be connected by something. If you observe by the formula, here we have R and here we have R. So you will be connected by dr for those two terms. As you can see, we need to find this and find this, but this we already know. It is 1 over pi given to you by the question. So we just need to find this right now, dV by dr. Okay. So we know V is given by this, so V is given by 4 over 3 pi r cubed. So dV by dr will be what? Will be times 3, that will be 4 pi r squared. Okay, so now we know this. Now, it says at the time when V is equal to this, so when V is equal to 288 pi, what is the value of R? So we know V is given to you by 4 over 3 pi r cubed is equal to 288 pi. So these two will cancel out on both sides. So r cubed will be what? Will be 288 times 3 divided by 4. That will be 216. So r has to be cubic root of answer. That will be 6. So basically, we are trying to find the value of dV by dt when r is equal to 16. So, which means at this value, what is the value of dV by dr? That will be 4 pi 16 squared. So it's 6, not 16. It's 6. You see, I make these kind of mistakes, so you have to always be careful when you work with numbers. That will be 144 pi. Now, so we know all the values that we need. Now we just have to rewrite this down in the equation to see what do we get. So finally, dV by dt will be dV by dr is 144 pi multiplied by dr by dt will be 1 over pi. That will be 144, that will be centimeters cube per second, because volume is cube, time is second. That's why this is your unit and this is your value for that dV by dt at which it is increasing by. Okay. So I guess one thing you guys may be confused is after finding this, you guys sometimes doesn't know what to do. So you have to look back at your question to see what is given to you. So we see that, hey, we have been given this information, so how can we use this? So if you look at this, here we don't have any V, but we have R. How can we use this to find R? And if you observe volume is given to you by this formula, so we can use this to find the value of R. So this is what I did here, and then we derive this value from that equation, and then finally replace everything back to your main equation to find that value. That is your question number 3. Okay, so now let's move on to question number 4. The diagram shows a right angle triangle ABC, okay, which the length of AB is 16 over root 2 and the length of BC is 7 root 3, okay, and the angle here is this. So part 1, we have to find the value of tan theta in the form of this. So one by one, what is tan theta? So you guys must know it is opposite side over adjacent side. So that will be opposite side is 16 over root 2 over A side will be 7 root 3. Of course, we can simplify this, so that will be 16 over root 2. We don't like to work with division. We can always rewrite this as this over 1. So we change division to multiply. Then we have to flip this upside down. You will have this. Now it is much simpler to work with. You will have 16 on top over 7 root 6. So this is your answer for part 1, which is 16 on top. So as you can see, we have to change this. Yeah, we have to put this up. So pretty easy as well. Let me simplify. So let me do this over here. So we have, right now we have 16 over 7 root 6. So what we can do here, we can multiply by root 6 and root 6 on both sides. You will have 16 root 6 over 7 times 6. Simplify, divide by 2, you will have 3. That will be 8. So you will be 8 root 6 over 21. As you can see, this will be your answer in this form, where A and B are integers. So this will be 8 root 6 over 21. Now for part 2, calculate the length of AC, giving your answer in the form of this, where C and D are integers and D is as small as possible. So if you observe, how can you find the length of AC? So obviously you will use the Pythagoras theorem, because you have a right angle triangle, two sides. To find the third side, you can just use that formula, right? So let's do this one by one. Let me find some space. So yep, here. So we know that AC square will be 16 over root 2 square plus 7 square, right? So AC square will be what? That will be 16 square will be what? 16 square will be 256 over 2 plus 49 times 3. That will be what? Well, this one seems to be, as you can see here, where's my square root? Everything has disappeared. Anyways, let's see what can we do. 256 divided by 2 plus 49 times 3. Okay, so it seems to be fine till now. We have this value, so here we have AC square, obviously. Now we have to simplify. So let me write this down again. So we have to find AC. That will be root of 275. Okay, so now we have to simplify in this form. Let's try to divide. So 275 divided by 25, that will be 11. So basically, I know that this can be written as 25 multiplied by 11, which means root of 25 multiply root of 11. Now I know this is the exact value, that will be 5 and that will be 11. Where this is as smallest as possible, as you can see this one is a prime number, we cannot simplify anymore. That will be root 11 and this is 5, which is an integer, and that will be your answer for question number 2. Now let's move on to question 5. So here we have to solve this equation. So as you guys understand by now, solving means we have to find the value of x, right? Find the values of x. So whenever you have x cubed 3, it means usually we must have 3 answers in most cases, right? So let's try to solve this. Now the main concept here is that whenever you have a cubic equation, at least for add maths, you have to solve by long division, or by trial and error. We have to find the factors. So let me find some space and write this down. So the question is, we have to solve. Here we have 2 x cubed minus 3 x squared minus 11x plus 6 is 0. So first let's call this f of x. Let f of x be this equation. Now, to find the first factor, we have to find by trial and error. So we have to look at the last number here and try to find the factor for this expression. Now, what is 6? What are the factors of 6? We can say it is 1 times 6, right? Or it can be 2 times 3. Now we can try these values one by one. Let's first try this one. It is up to you. You can choose any of these if you want to. I want to try 2. Let's try 2. So what is f of 2? That will be 2 times 8 minus 3 times 4 minus 22 plus 6. So let's see what do you get. If you get 0, that is good news. So 2 times 8 minus 12 minus 22 plus 6. Sorry. That will be 16 minus 12 minus 22 plus 6. No, this is minus 12. It is not 0. So which means it is not a factor. So we cannot take this one. Now we can try 3. Why not? Or try 1. So f of 1. That will be 2 times 1 minus 3 minus 11 plus 6. Let's see what do we get. That will be 2 times 1 minus 3 minus 11 plus 6. That is minus 6, so not good still. So let's see what else can we do. So we can also look at the fact that 6 is also what? It is also minus 1 times minus 6. So let's try to use minus 1 to see what happened. F of minus 1, that will be minus 2 minus 3 plus 11 plus 6. That is also not good. So minus 2 minus 3 plus 11 plus 6. That is 12, so not good. So something else. We can try to use 3. Right? So f of 3, that will be 2 times 27 minus 3 times 9 minus 11 times 3 plus 16 plus 6, sorry, not 16. So 2 times 27 minus 3 times 9 minus 33 and plus 6, and that is 0. So great news. We know that when the value of x is 3, f of x, which is 3, is equal to 0. So this is called the remainder theorem. So from this we can conclude that this is a solution. If you send this over here, it will be x minus 3. This will be called is a factor of that expression. Is a factor of f of x. That's the first factor we have found by trial and error. So as you have seen, even for me, I don't know what it is. I have to try one by one to see which one works. So don't think that I know already. I always try and see what happens, right? Now, by first finding this, now we can find the other factors of that equation. So to find the other ones, we perform long division. That will be 2x cubed 3x squared minus 11x plus 6. Now we know this one is a factor, so x minus 3. So questions will be as follows. So how can you make x become 2x cubed? So you have to multiply it by 2 first, and then by x squared, right? That makes sense. So take this, multiply by this. You will have 2x cubed minus 6x squared. This will cancel out. Now, minus 3 minus minus 6 will be what? So minus 3 plus 6, that will be 3x squared. Minus 11x plus 6. Now, next one, how can you make x become 3x squared? So multiply by plus 3x, right? So you will have this multiplied by this will give you 3x squared minus 9x. Now this will go away, and this will be minus 11 plus 9, that will be minus 2x plus 6. And finally, how can you make x become minus 2x? Multiply by minus 2. That will become minus 2x plus 6. That will be giving you 0. So whenever you perform long division with a factor, it will always give you 0. If it doesn't give you 0, you have made a mistake. So keep that in mind when doing this kind of questions. Now, from this we can conclude that from here, f of x can also be written as x minus 3 multiplied by this one plus 3x minus 2. Now we can factorize the other part as well. If you observe, it is a simple quadratic equation. 2x squared will be 2x times x, and 2 is 2 times 1, right? To get plus 3, you have to have plus 4 minus 1. Now, of course, we're trying to find the values of x, solving equation. So equate that to 0. X has to be 3, x have to be half, and x has to be minus 2. So that is your answer for question number 5. So let me write this down. 5, x will be 3, x will be half, and x will be minus 2. Okay, so let's move on to question number 6. The diagram shows a line y equal to 12 minus 2x, as you can see. Okay, the points Q is xy, lies on the line, and the points P and Q lie on the axis, such that OPQR is a rectangle. Okay, these are the given information on the diagram itself, as you can see clearly. Now, part 1, we have to write an expression in terms of x for the area A of the rectangle. Now, first thing first, it will help to know how do you find area of a rectangle. So you know that area is length times width, right, for rectangle. Now, length will be this one, and the width will be this one. So let's first find the points R and P. So what is the point R and what is the point P? Okay, so if you think, so we know that P lies on the x-axis, so which means on the x-axis the value of y has to be 0. And we know that R lies on the y-axis, so the value of x has to be 0 for R. Now, what is the other value? Pretty easy. Look at this point. It will be on the same level of this, so same level of y, so R will be y here, and this will be same level at x, that will be x right here. So to simplify, to see what it means that the distance here is x, and the distance here is y. So the area will be length is y times x, but now we can change y because we know that y is equal to this. That will be 12 minus 2x times x. Simplify to, so area 12x minus 2x squared. That will be your answer for part 1. Okay, so now for part 2, given that x can vary, find the value of x at which a has a stationary value. Again, many times you will have the same kind of question. So whenever you see a has a stationary value with x can vary, you have to know that you are trying to find dA by dx. And this happens when this is equal to 0. So let's find that. So we know a is this, so from this we can conclude that dA by dx is what? Differentiating this will give you 12 minus 4x. Now equate to 0, right? And that will give you 4x is 12, x will be 3. Okay, so we know this x value. What is a y value? Y will be replaced here, 12 minus 6, and that will be 6. So the stationary point will be 3 and 6. So from the x value, so you just need the x value. That will be the value of 3, right? And for part 3, we have to find the stationary value of a and find its nature. So pretty easy. To find the value of a, the stationary value of a, so we know a is equal to what? It is equal to 12x minus 2x squared. And we know this is the stationary value of x, so we replace x in here to see what happens. That will be 12 times 3 minus 2 times 9. That will be 18. So 18 will be the value of a. So of course this is units square because it is area. Now how do you find its nature? You can look at the second derivative, which is d2a by dx2. So pretty easy. That will be the value of minus 4. Now since it is negative, because as you can see here, you can just have to redifferentiate this term, you will get minus 4. Now because it is negative, it will be a maximum value. So you can just write, since this value here, so this value is less than 0, we conclude that the stationary value of a is a maximum value. Max value. Okay, that will be your question number 6. Okay, so let's move on to question number 7. So part 1, sketch the graph of y for this domain, showing the coordinates of the points where the graph meets the axis. Now, part 2, on the same diagram, sketch the graph of y equal to x plus 6 and solve this equation. Okay, so there's many ways of doing that question. So let me find some space first. Okay, so I think I'm continue on. Let me try to do on this page first. Why not? So the first thing I like to do is, whenever I deal with modulus graph, I like to first ignore the modulus. So what do I mean? I will rewrite it down, assume that y is equal to 3x plus 9. That's my first step. Now, of course, I will try to find the values that I need to find. So this is if you observe, this one is what? It is simply a straight line. If you observe, right? It is y equal to 3x plus 9, so it is a straight line. Now, let's find 2 points where we can connect, and we can just draw them. So, let's say x equal to 0. What is the value? Y will be 9. Let's say y equal to 0. X has to be minus 3. If you can see, right? Pretty simple. So 2 passing point will be 0, 9, and minus 3, 0. This will be the 2 passing point for this line. Now I can draw this line pretty easily. Let me find some space. Okay, so I will do this here. So I don't have my ruler with me. So make sure when you draw graphs, use your ruler, okay? So don't copy me. This is pretty dumb, but yeah. Anyways, I have to use what I have for now. So this will be my y-axis. This will be my x-axis. For example, this is going to the value of minus 5. Okay, anyways, that is my x, and let me continue this in case it goes up. My value of y. So here I have 2 points, which is as you can see, we have first assumed that y is equal to 3x plus 9. So we have 2 points here. We have the point of 0, 9, and then minus 3, 0. So minus 3, 0, let's say it will be somewhere over here, for example, right? That's my first point. And then we have 0, 9 should be somewhere over here, for example. So from what you can see, my graph will look something like this, right? It will be a straight line joining these two. Right, that is my first graph. Now, you have to understand that when dealing with modulus graphs, so after doing my straight line, now I can say that, hey, because I have this graph, now I know my real answer has to be modulus 3x plus 9. Now, what is the meaning of modulus, right? It means that the graph cannot be negative. So anything that goes below 0 has to be reflected upwards. For example, here, this part is below 0, so it will be reflected upwards. So what do I mean? So I just have to erase this one, erase it, and then redraw this in this direction as a reflection of itself. It will be somewhere over here. Now remember, the domain has been defined for minus 5, 2, value of 2. So just show that we are stopping at minus 5 and we are stopping at 2. For example, just show that we are stopping our graph between these two domains, just to be safe. Now we have to show the axis where it cuts our axis. This is the value of 9. It's the value of minus 3. So we have to show these 2 points for your full mark as well. That is for part 1. Okay, so of course you will have to erase this part because this is not your real answer. It is just an example where we can use to reflect on top to find the real answer. Okay, now for part 2, on the same diagram, we have to do what? We have to sketch y is equal to x plus 6. Now again, this one is a straight line, so we can just find 2 points and draw this line. So x is 0, for example, y has to be 6. So my first point will be 0, 6. If y is 0, x has to be, so we don't have space for minus 6. Let's just not use this. Let's use y is the value of, for example, let's choose 2. Why not? X will be minus 4. So you will have minus 4 and 2 as your other passing point. So now we have 2 passing points. We just have to try to sketch that on the graph and then joining them by a straight line. So 0, 6 will be somewhere over here. That will be 6. And minus 4, 2 will be somewhere over here. For example, right? It will be somewhere over here. Now we just have to join them straight by these 2 points. Of course, you must use a ruler. Don't copy me. It has to be straight. And this will be labeled as y equal to x plus 6. And you have to label your other one as well, which is this one, as y equal to modulus of 3x plus 9. Okay, so this will be your graph for question part 2. Now finally, we have to solve this equation. Now of course you can use your graph to determine that, or you can just solve it by yourself here. You can always, so there's 2 ways to solving this. We can square both sides, or we can just solve it as this. We can say that will be this plus 9 is equal to x plus 6, or we can have 3x plus 9 is equal to minus the value over here. That is one way. And the other way is you can always just square both sides and then find the values of x. That is the other way. So send this here, we'll have 2x, and that will be minus 3. X will be minus 1.5. That will be 1. So 3x plus 9 has to be minus x minus 6. That'll be 4x. That will be minus 6 minus 9 will be minus 15. And then finally x has to be minus 15 divided by what? Divided by the value of 4. That'll be, sorry, minus, sorry about that, minus 3.75. Okay, so that will be your answer for question part 3. Question 7. Let's move on to question number 8. Excuse me for my coughing. I think I just talk too much sometimes. My throat get dry. As you can see, I try to film those videos in one go, and that's the main reason why I don't check answers online, because sometimes, you know, if I do the questions, if I go back to check the answers, if let's say if I made a mistake, I will have to reprint the paper again, so it's gonna be a lot more work, you know. So that's why I try to do this in one go and see what happens. Now part 8, we have what? Write down the first 4 terms in ascending powers of x of this expansion. So one by one, how do you first expand this? So pretty easy. Let me find some space again. So we have the term to expand is the expression 1 minus 3x power 7. Excuse me. Now, so we need to find the first 4 terms in this expansion. So let's begin with one by one. So first term is 7, choose 0. Then you will have first term and then minus 3x. As you can see here, this is 1 minus 3x. If this is 0, this also will be 0. 7 minus 0 will be 7. And 7 choose 1, that will be 1 minus 3x. This is 1, this will be 1, this will be 6. And 7 choose 2, that will be 1 minus 3x. This is 2, this will be 2, and this will be 7 minus 2 is 5. And finally, for the fourth term, that will be 3 here. 1 minus 3, this will be 3 here, and this will be 4. Right. Now let's expand one by one to find the following values. This is 1 times 1 times 1. 7 times 1 times minus 3x plus, what is 7 choose 2? That will be 21. 9x squared plus 7 choose 3. 35. Okay, that will be 1. So here we have plus, obviously. That will be plus, so it becomes minus 21. X, that will be plus 21 times 9, that will be 189. And finally, here we have 35 times minus 27, that will be minus 945 x cubed. So these are the first 4 terms of this expansion. So let me write this down here for my answer. So here my answer will be, we have 1 minus 21x plus 189x squared minus 945 x cubed. My first 4 term of this expansion. Now for part 2, we have to find the coefficient of x cubed in the expression of this. Okay, so pretty easy. Let me write this down. So right now we want to expand this term, which is 5 plus 2x multiplied by 1 minus 3x power 7. Now, as you can see, if you were to expand this, what you will have? You will have 5 multiplied by this, and then plus 2x, 1 minus 3x, 7. Now, first thing first, we have to understand what is the coefficient of x cubed. For example, if you have a, which is a constant, x cubed, this value of a is what you call the coefficient of x cubed. So for example, so same concept, I hope you understand now, but same concept again. Let's say you have to find, you have a x squared. So this will be called the coefficient of x squared. So just the value in front of this variable thing, you will have the coefficient. Anyways, now we have to use this expansion to find the answer, which is the coefficient of x cubed. Now this we know already from the first term. If you observe, what is that? So this is 5 times 1, 21x plus 189 x squared minus 945 x cubed. Sorry. So for this expansion, we only care about the x cubed term. So if you observe, this is a constant. Multiply by this, we don't need to, but we do need to multiply by this because we only care about the term in x cubed. Okay, so same thing here. When you multiply this, for example, we have 2x, then we have 1 minus 21x plus 189x squared minus 945 x cubed. So here we have x already, we just need to multiply by this one to obtain something in 2x 189x squared. So simplify, that will give you what? We have minus 5 times this, that will be 5 times 945, that should be 4,725 x cubed. And here we have plus in between, so you write plus. And here you have 2 times 189, that should be 378. So simplify. Minus 4725, that will be minus 4347 x cubed. So the coefficient of x cubed will be the value in front. So this value will be your answer for question part 2. So this is what? Minus 4347. Okay. Now for part B, we have to find the term independent of x in this expansion. Okay, so we just have to find the term where there's no x in this expansion. So I think it's pretty straightforward too. We just need to do this by trial and error. So that's the main idea here, by trying out to see what happens. So one way of doing this is you can expand everything. It is up to you. You can do that, but it will take a lot of time. Or you can choose. You can just think, let's suppose I don't know. Let me try to expand the term as normal. For example, the first thing I will do is I will write 9. Choose something. I don't know yet. I know this is x squared. And this will be 2 over x. Now, I have to choose which term I will put here and which number I will choose to put here so that we don't have x anymore. For example, I can think in my head, if you try 1, it will not work out. If you try 2, so if you try 2 here, you have square. Here you will have something more, which is not good. So if you try, let's see, if I try 6, what happens? So if you try 6 here, for example, that will be 6 also here. 9 minus 6 will be 3. So if you observe, what is 9 choose 6? That will be 84. That will be x power 6. That will be 2 power 6. That will be 64 over x power 6. So you can see they will cancel out. So you have 84 times 64. That will be 5376 as a term which is independent of x. That will be question number 8. Okay, so let's move on to question number 9. Given that y equal to this expression, we have to show dy by dx is this, where k is a constant to be found. So one by one. Okay, so as you can see here, y is a fraction, so you have to use the quotient rule. So let's do that. So dy by dx will be what? So first thing first, we have to write the base as it is. So 4x plus 12 power half. Then multiply by d by dx of the top, that will be 1, minus the top as it is, multiply by d by dx of the base, that will be half. That will be 4x plus 12. That will be, you have 2, of course, add 1, 3 over 2, sorry, minus 1, this is differentiation, minus 1, that will become minus half, right? So half minus 1 will be minus half, and then multiply by d by dx of the value inside, that will be 4, right? I hope that makes sense, right? Because, let me write this down here then, because I know it's kind of confusing sometimes. There's not enough space. Let me write this down. So when you have to find d by dx of what? Of this term, so let me write this down here. So we have y is given to you as x plus 2 over 4x plus 12 power half. So you have to find dy by dx. So that will be found by using the quotient rule, because you can see this one is a fraction, right? So we have to first write down the base as it is. So we have 4x plus 12, that will be half, right? And then multiply by d by dx on the top value, that will become 1, then minus the top value by itself, multiply by d by dx of this. So what is a d by dx of this? If you observe, d by dx of 4x plus 12 power half will be what? That will be, first thing first, we have to multiply by the power, then write the value of the inside as it is for now, then power minus 1 will be minus half, then multiply by d by dx of the value inside, that will be 4. Simplify, this will go away, that will be 2, so you have 2 over 4x plus 12 power half. So you have to write this down here, and this will be 2 over 4x plus 12 power half. Now, of course, everything here will be divided by the base square, which will be 4x plus 12 power half square. Okay, so now we have to try to simplify this term to see what can we have. So let's first simplify the top values. So here we have square root, for example. That will be we can write square root if you want to, but let me see what they wrote here. So we don't need that, so we can just keep it as it is. That will be 4x plus half, so for plus 12, not half, minus 2 x plus 2 over the value of 4x plus 12 power half. Now this is just the top term. As you can see here, we're trying to simplify this. So as you can see, this one is a fraction with different bases. So what do? You have to simplify. So make them become the same base, so multiply by each other. So this will be 4x plus 12 power half. Now you have to cross multiply. You will have what? This will become 4x plus 12 simply because half plus become 1. So you have the value of it inside. Then minus 2x minus 4. So you have to know that if a power half multiplied by a power half, what happens? Because they have the same base, you can just add them together. Half plus half, that will become a power 1. So same thing here. This is 4x plus 12, 4x plus 12. So same thing, same concept as a. Then you have to add those powers together, becomes 1. So you just have a as your answer. So a will be, for example, in this one will be this, just the value inside. Now this will become 4x minus 2, that will be 2x. That will be plus 8 over 4x plus 12 power half. Okay, so this is the top value right here, right? Now we let's see. Let me write this down over here now. So by doing all this, we have realized that d by dx can also be written as 2x plus 8 over 4x plus 12 power half, and divide by, don't forget to divide by the base, which is 4x plus 12 half, and then 2 square. So if you observe, this can be just the same thing. That will be 1. Now we can combine them together. If you think about this, let me write this down here because we need more space. For example, if you have 1 over a power half divided by a 3 over 2. Sorry, let's just use, let's not use that because it's not the same. Let me use, here we have half, so here we have 1, for example, right? So let me just write this again because it can be confusing right now. So let's say we have 1 over a power half dividing by a power 1. So what is a power 1? It is also written as a over 1. Makes sense, right? Because if I tell you a is what? It is a divided by 1. Just like what is 2? 2 can also be 2 divided by 1, which is the same thing. Now, when you see divide here, we don't like to work with divide. We can change divide to multiply. So 1 over a half, change divide to multiply. So now we have to flip this upside down. That will become 1 over a1. Now we can multiply them by each other. You will have 1 on top. And here we have a half multiplied by a1. Now, because they have the same base, as you can see, we can combine them together. That will be 1 over a, same base. And here we have multiply, so you have to half plus 1. That will be 1 over a. That will be 3 over 2. So same concept here, except in the main question, our a is actually 4x plus 12. So you will have the same concept here. You will see that this will become 2x plus 8 over 4x plus 12, 3 over 2. Now, as you can see, we can factorize this. You will have, if you take 2 outside, you will have x plus 4 and the same base. No space. So let me write this as this. So you get the idea. This looks like this, where k is the value of 2. Now for part 2, we have to hence evaluate this integration. So whenever you see hence, what does that mean? It means you have to use the previous answer to find this. So let's see what can we use from this. So we know that when we perform differentiation, which is we know that d by dx was found to be 2x plus 4 over the value of 4x plus 12 power 3 over 2. And the value of y was given to you by x plus 2 over 4x plus 12 that will be half. So the concept here we have to use is we have to understand that the integration is a reverse process of differentiation. So what do I mean? When we had y, when we differentiate y, we obtain this. But when you have dy by dx, if you were to integrate dy by dx, you have to get back your same y value. So this is why it's called the reverse process. So the idea here is that if I were to integrate this thing, which is 2x plus 4 over 4x plus 12, 3 over 2 by dx, I am supposed to get back the same value of y. That's the main concept we have to use from part 1 to find your answer for part 2. So that's what we have right now. Now what is the question? We have to integrate this between 13 and 1, x plus 4 over this. So here we don't have the value of 2. So pretty easy. We just need to make this one become subject, which is without the 2. So how do you remove the 2? We can just divide by 2 everywhere, right? You will have x plus 4 over 4x plus 12, 3 over 2. That will be integration of 13 over 1. That will be dx. And since we're dividing by 2 everywhere, we have the 2 here. That will be 4x plus 12 power half. And the limits will be 13 and 1. So let's see what happens. That will be, first one will be, 13 plus 2 will be 15. Over the value of 2, that will be 4 times 1. So 4 times 13 plus 12, that will be 64 power half. That will be 8. So that will be 8 minus, that will be 3 over 2 times. That will be what? So 1 here, 16 half will be 4. So let's see what do we get. So 15 over 16 minus 3 over 8. That will be 9 over 16 as your answer for question part 2 of number 9. So as you can see, most questions, they are related to each other. So when you do part 1, you have to use part 1 to find part 2. But the basis is you have to understand the main concept. So if you understand the main concept of math, you can do almost any questions, right? For A levels, for add math, should not be that tough. Okay, now let's move on to question part 10. So we're given that log to the base of px is 6, log to the base of py is 4. So we have to find the value of first one is this. So we have to understand the laws of logarithms to be able to simplify this. So one by one. So we know that we can break this down into log, the same base of p, x squared. Now when you have divide, it can simply be minus, right? So that would be p and y. So the law here we use is we understand that, for example, whenever you write log to the base of p, for example, of a, minus log base of p of b, it can become log to the base of p of a, because of minus become divided by b. Now this can also become this, right? So this can also become this because of the laws of logarithms. Now we can simplify this. We can send this to the beginning. That will become 2 log px minus log py. That will be 2 log px will be what? As you can see, this is 6 minus log py will be 4. So 12 minus 4 will be 8. Okay, this will be your answer for part 1. Now for part 2, we have to find this. So this one is also something we have to know. Is whenever we don't have the base we are looking for, we can break this down into pieces. For example, we can do this. So when you have log base of yx. So here we care about base of p, but there's no p to be seen anywhere. So we have to rewrite this as log base of p. So we have to force a p into this. That will be x here on top. And then log base of py. That is something you have to know for the laws of logarithms. So log base of px is given to you by 6. Base of py is 4, that should be 3 over 2. Okay, so now let's move on to the next part, which is part B of the equation. So here we have to find what? Find the value of 2 power z, where z is equal to this. Okay, so step by step. So 2 power z, z is 5 plus log base of 2, 3. Now we have to know the laws of indices. For example, let me write this over here. When you have, let's say you have a base of 2, when you have a plus b. Now you can break this down in terms of 2a. When you have plus, it can become multiply 2b. So same concept here. We have base of 2, 5 plus, so plus is here. We can break this down into 2 multiply 2 log of base of 2, 3. Now 2 power 5, pretty easy. It is 32. That will be 32. Now this one will be simplified to 3. Your answer will be 32 times 3, that should be 96. Now, I know this is not very common here. We don't see this very often, but let me explain how did we find this. So for example, right now we have what? Right now we have 2 log base of 2 of 3. Right. So we don't see this very often. Something we see very often is what? Is whenever you have exponential ln of e. So ln of e. So ln of some value. Let me change e because that will be kind of redundant. So we have exponential ln of a value of 3, for example. So this we have seen many times, and we know that this will be cancelled out to 1, so your answer will be 3. But now if you want to simplify this, if you observe, what is this actually? So exponential, what is ln? Ln is log to the base of e value of 3. So the main idea is that if you have a base here, and if you have power of log of the same base, they will cancel out to 1. Not 1, but they will just cancel out, and then you will have this value here as your answer. So same concept applies here as well. When you have the base of 2, and you have power log of the same base, this will just cancel out, and you will have this as your value of 3. So that's what happened here. That's why you have 3, and this will be 96 as your answer. Now for part C, express 512 as a power of 4. Very interesting one. So it is pretty easy as well. Let me write this down here. So 512 root, right? So first thing first, 512, we can just find the, let's try to find the multiples in terms of for 512. So what can we do? If you try to find the factors, not the prime factors, you have 512 divided by 4. What do you get? That will be 128, and divide by 4, that will be what? 132, and divide by 4, that will be 8, divide by 4, that will be 2. Let's check, right? So 4 times 4 times 4 times 4 times 2, 512. Okay, so basically we have realized that this will give you the value of what? So 4 power 4 multiplied by 2 power 1, and that will be square root, of course. Now let's see how can we simplify this. So can we do something about this? I think yes, we can, because that will be kind of ridiculous that we cannot. So 2 can be what? 2 can be written as what? If you observe, 2 is simply square root of 4, if you think about this, right? So that will be 4 power half. Yeah, if you think about this, right? So that will be 4 power 4 times 4 power half inside of this. Now simplify, this will become 4 power 2 multiplied by 4 this. Now simplify again, that will become this, and this will give you 4 1 over 4. If you if you because if you understand the laws of logarithms, when you have the same base 2 multiplied by a3, for example, we can just add them together. So same idea here, same base, 2 plus 1 over 4, that will be what? That will be this, so which is also written as 4, that will be 9 over 4. Because if you were to expand, mixed number, so we have 2, 1 over 4. 2 multiplied by 4 is 8, 8 plus 1 is 9, so 9 over 4. So this will be your answer for in terms of power of 4. That is 4, 9 over, so 4, 9 over 4 as your answer. Okay, that will be question number 10. Let's move on to question number 11. So here we have to solve for the value of x between 0 and 3 radians, the equation of this, giving your answer correct to 2 decimal places. Okay, let's see what can we do. So first thing first, make sin x become subject, so you have sin x is 3 over 4. Now because it is positive, it will be in the first quadrant and in the second quadrant. So now again, because it is positive, we can solve directly. X will be sin inverse of 3 over 4. Okay, so sin inverse 3 over 4, that will be in terms of radians, that will be 0.848. Also, it will be the other value, which is pi, minus answer, that will be 2.294. Okay. Now let's check if the answer is between, so it is between, so let me rewrite these answers now because we need to provide the answer to 2 decimal places. That will be 85 and 2.29. That will be the answers correct to 2 decimal places. Now for part B, we have to solve another equation between this. Okay, so here we have a few things we can simplify. Let me, of course, find some space so we can explain this question properly. So we have what? We have 4 cosec y is equal to 6 sin y plus cot y. Now, what is cosec? You have to know it is 1 over sine. What is cot? It is 1 over tan y, or you can write it is cos y over sine y. So let's replace them by these simple values, simple things that we know how to work with. So 4 will be 1 over, so cosec will be 1 over sine y equal to 6 sine y plus cot y is 1. It is not, so it is cos y over sine y. Now as you can see, we have a base of sine y everywhere. We want to kind of eliminate that. We can try to multiply everywhere by sine y. So you will have 4 is equal to 6 sine square y, and here you have what? Plus cos y. Now we cannot simplify cos y naturally, but we know that we can simplify this, right? Because if you think, we have a formula we can use, which is sine square y plus cos square y is equal to 1. So if you find sine square y is 1 minus cos square y. So replace back in the main equation, you will have 4 is equal to 6 times 1 minus cos square y plus cos y. Now simplify, you have 4 is equal to 6 minus 6 cos square y plus cos y. So let's send everything to one side. You will have 6 cos square y minus cos y. And we have plus 4 minus 6 will be minus 2 equal to 0. Because here we have 4. We send this over here. 4 minus 6 will be minus 2. Right. Now finally we can try to factorize. So to make our life easier, what we can do here is we can try to change cos y in terms of u. If you observe, that will be 6u squared minus, so this will be u minus 2 is 0. So we can factorize. What is this? We can, what is 6u squared? Can be 3u times u. What is 2? 2 is 2 times 1. Now to get minus 1, we have to have minus 3 plus 1. So minus 3 plus 2 to get minus 1. Okay, so just to repeat, so we know we have 6u squared. So what is 6u squared? It is 3u times 2u. So 2u will be over here, right? See, I made a mistake almost. You can see, it's always good to double check. So let's try again. So factorize, we have two brackets. That will be 0. Here we have 3u times 2u, because that is 6u squared. Now 2 is 2 times 1. We have 2 here and 1 here. Why? Because we need to get minus 1u. Now to get minus 1u, we have to have minus 4, right? 2 times 2 is minus 4. So minus 2 times 2, minus 4. Then plus 3. So this times this will be plus 3. You will get minus 1. So minus 4 plus 3 is minus 1. So this is your factorization. Now, u is equal to 2 over 3. And u is equal to minus half. Now again, we're not trying to find the values of u. We are trying to find the value of y. So cos y is 2 over 3. And cos y is minus half. So one by one, let's begin for this one. As you can see here, the value of cos is positive. It will be in what quadrant? It will be in your first quadrant and your fourth quadrant. So y will be cos inverse of 2 over 3 directly. That will be what? 2 over 3, that is in terms of degrees now, I think, yeah, degrees. That will be, let's try again, cos inverse 2 over 3 degrees, that will be 48.2. But also we have to look at this one, which is 360 minus 48.2. That will be 311.8. Okay, so now for this one, when cos is negative, we have to understand that we are looking at different quadrants. It will be in the second quadrant and also the third quadrant. So here this is what? This is 180 minus theta, and this is 180 plus theta. Right, if you understand. Now, because it is negative, we are trying to work with the angle of theta. As I've always done in the past, whenever it's negative, I like to work with a fake angle at first. Theta is equal to cos inverse of the positive value. So here we have negative, so we first try to find theta. Now, theta will be given to you by 60 degrees. You can always check. Cos inverse of 0.5, that will be 60 degrees. Now, this is not your answer. You have to find y. Y will be found according to your quadrants, which is 180 minus theta. That will be 120. But also 180 plus theta. So 180 plus 60, which is 240 as well. So as you can see, you have 4 answers for your value of y between 0 and 360. And that is your question number 11. Okay, so now let's move on to question number 12. So answer only one of the following questions. So I guess okay, fine, I will do both. It is given that f of x is given by this. Find the values of k for which the function is equal to 3 has no real roots. Now, as you can see, whenever you see this, you have to understand that we are trying to prove b squared 4ac is less than 0. Right? That's the main thing about have no roots, have one root, have more than, have two roots, for example, right? That's the main thing we are trying to find now. Now, what is f of x? We know already. Let's just replace that. F of x is 4x squared plus kx plus k is equal to 3. Now let's send everything to one side. You will have what? You have 4x squared plus kx plus k minus 3 is 0. This is a, this is b, and this is c. So b squared will be k squared minus 4 times a times c has to be less than 0 because it has no roots. Right. Now that will be k squared minus, that will be 16, k minus 3 less than 0. Now let's continue on this side. Why not? You will have k square minus 16 k and then minus the value, so this will be plus 48 is less than 0. So let's check. 16 times 3 is 48. Good news. Now whenever you have this kind of expression and with less or more, sometimes more, right, we have to try to find the critical values of k, which means we just have to equate that to 0. So k square minus 16k plus 48 equate to 0. Now we're just finding the critical values, which is not the answer, but it helps us to find the answer. That will be k times k. Now what is 48? 48 can be what? 48 can be 12 times 4, which is perfect in this case, right? 12 times 4. To get minus 16, we have to have minus 12 minus 4. That makes sense, right? So finally from this, we can conclude that k can be 12 or k can be 4. But this is not the answer. This is the critical values. Now to find the answer, we have to look at the graph. Now, this is my line of 0, right? For example, because the coefficient of k squared is 1, it is positive 1, the shape of the graph will look something like this. That's the main idea. Okay, now this is the critical values, which is the point of intersection. That will be 4 here, and that will be 12. So we're trying to find the value for which it will be less than 0, which is below the line of 0, which is this side. Okay, so this is only possible when k is in between 4 and 12. And this will be your answer for part 1. Okay, so now let's move on to part 2. In case where k is 10, so k is 10, right now f of x is what? F of x will be k, so 4x squared plus 10x plus 10. Okay? We have to express f of x in the form of this. So we have to try to complete the squares of f of x. So step by step, as always, whenever you have the coefficient is not 1, we have to make it become 1. So we have to first factorize the 4 outside. For example, so take out 4, you will have x squared plus what? So 10 over 4 is what? 10 divided by 4, that will be 2.5. So 2.5 x, and then we can just leave the 10 outside. Now we can try to move on to the next step, which is what? Which is we have 4 here, x squared plus 2.5x. Now we have to add a value. The value that we add will be the value right here, 2.5 divided by 2 squared. Okay, and then of course when you add a value, you need to minus the same value. So let me write this down here, so you don't change your function. That's the main idea. That will be 1.25 squared, but of course it is inside the bracket with 4. You also have to give it a 4. That makes sense, right? So 4 times 1.25 squared, that will be this. 10 minus answer will be this. So this will become 3.75. Okay, so now we can simplify this. So 4 will be outside. Here we have x. Change to x. We are trying to complete the squares now. So here we have plus. That will be plus. And the value inside is 1.25. And square will be square plus 3.75. Okay, so now we are almost done. We have to bring this value inside. If you observe, what do we have? We have what? We can just, what is 4? 4 can also be 2 power 2. But now you can just take 2 right here and x plus 1.25 and put the power together. You can see we can also write this like that. Now plus 3.75. So finally, this will be what? We can bring this in. You will have 2x plus 2.5 square plus 3.75. Okay, so that will be this in this form where a, b, and c is seen right here. Now, find the least value of f of x and the value of x for which this occurs. So the least value of f of x is very simple. Is the value at the end right here. Okay, so you have to know whenever you express your equation or your expression in complete square form, the value in the end that remains is always the stationary value. And now the case right here why it is a minimum value is because it is positive 4. You know it has to have a minimum point, which means a minimum value. This will be the so this is actually the minimum y value of that place, not the value itself. So we have to use the knowledge of this to try to find what is that value, if you can try. I think it is, because this is y. Sorry, my apologies, I confused myself for a bit. So this is basically your function y. So from this we conclude that so this is not y, this is f of x. Again, you see what am I doing again? So this value right here will be your minimum value of the function, so which is 3.75. So just to recap, whenever you complete the square of f of x or of an expression, the value of the n will be your minimum value or the y value. Right. Now let's see what else we need to find. So, and the value of x at which it occurs. So the value of x pretty simple as well. We have to use the same information that we have used here. We have to look at the value on the inside to find the value of x at which it occurs. So we just have to take this value and then equate that value to 0. X will be what? Will be minus 1.25. So this is the value at which this value occurs. That will be the answer for part 3. Okay, so which is x is minus 1.25. Okay, so now let's move on to the other part. Wow. I'm just thinking that I've been doing these papers non-stop, so non-stop, when it is kind of long, but I try my best to stay focused. And this is the reason why usually I make mistakes, because I try to go kind of fast as well as try to avoid mistake, but you get tired at one point by talking and trying to do questions at the same time. But anyways, let's move on to part 2. Function f and g and h are defined by this, as you can see on the question right here. Right now, part 1, we have to write down the range of f. So when we speak about range, usually we are referring to the y values of f. So the main idea here is that what is the value that f can take now or can go to. So if you observe, f is simply what? It is a curve, right? It is a minimum curve because of the coefficient of x squared is 1. So basically we'll have a shape of this. So let's first assume that we don't have the 1. What is the shape of the curve? It will be right here in the center, right? If you don't have the 1. Now what does the 1 mean? 1 means you have to go up by 1. So that's what it means. So basically the shape will be something like this, where your point here is the y value of 1. So as you can see, write down means not very hard. It is only 1 mark, so your value f has to be more or equal to 1. That is your range of f. As you can see here, the y value, it's always from this, it's always going up, right? So the range is always up or down value, so the y values. Now for part 2, find the value of g f of 3. Now the first thing I can do here is I can just break this down. G, let's first find f of 3. So what is this value? Replace in your function, you will have f of 3 is equal to 9 plus 1, that will be 10. So here we have to find g of 10. That will be 20 minus 5, that will be 15 as your answer. Okay, now for part 3, solve the equation, this and this, to find the answer. So again, we can do step by step. So let's do this step by step. Why not? So first, what is f g of x? That will be f of g of x. That will be f of x is what it is. X squared, x will become g of x squared plus 1. G of x squared will be 2x minus 5 squared plus 1. Right? Let's simplify. That will become 4x squared minus 20x plus 25 plus 1. That will be 4x squared minus 20x plus 26. Okay, and that is the one on the left hand side. How about this one? G inverse of 15. So let y equal to g of x. That will be y plus 5 is equal to 2x. So 2x has to be y plus 5 over 2. So of course, not 2x, but x. Right, so from this we conclude that g of x has to be x plus 5 over 2. Now what is g of inverse of x of the value 15? That will be 20 over 2, and that will need to be 10. So replace the values that we know in the main equation. What do you get? You will get on one side, you will have 4x squared minus 20x plus 26 have to give you 10. simplify 4x squared minus 20x plus 16 equal to 0. Now we can definitely simplify this. That will be what? That will be x squared, so divide by 4 everywhere, minus 5x plus 4 has to be 0. Now factorize, as you can see, this will be x 4 times 1. To get minus 5, we have to have minus 4 minus 1. As you can see here, we have two values that we have, which is x can be 1 or x can be the value of 4. So this is your answer for question number 3. Now for part 4, on the same axis, sketch the graph of y equal to h of x and the graph of the inverse y equal to h inverse of x. Indicate clearly which graph is this, which graph is this. So the main idea here is, again, you must know by now, I think we have done this question probably over 20 times, right? So we have to know that y equal to h of x is simply what? Is reflection of y equal to h inverse of x in the line y equal to x. So that's the main idea. So once you kind of show this, you actually get 1 mark easily, and then the other one will be the shape of your graph. So let me just find some space here. So I guess you guys will also need the graph for the functions. Let me do this for you as well. So we know that h of x is given to you by 2 power x. So the main idea here is that when we increase the value of x, we know the value of h of x will also be increased. So the shape will be something like this as the value of x increases. That's the idea we need to at least have in our head. Now, what is the graph exactly? So let's think. Let's find a few points that we can locate. For example, if the value of x is 0, what is the value of h? That will be 2 power 0, that will be 1. So the first point we have is 0, 1 that we can use. Okay, so let's do that. So this is my y-axis, and this is my x-axis, x, y. My first point of will be 1, 0. So the idea here is that now my graph of 2 power x will be something like this. From here, going up, crossing this line, and of course, keep going up. And now, after drawing this line, we have to understand that the relationship between the graph is the reflection in the line y equal to x. Of course, you have to use a ruler while you draw this. This is the line y equal to x. And my inverse function will be a reflection in that line. So if you observe, it will be something like this. So almost try my best to make a reflection for this one. As you can see, this will be my other line. So let's label them. This will be h inverse of x, and this one will be h of x. So I just thought I might as well give you the graph for the answer as well. So this will be the graph. As you can see, you have to have the basic understanding that it is a reflection, and also find a point whenever you have to draw the line to understand where is the direction, at least where's the starting point. Because sometimes what may happen is that you may just believe that it will be something in this shape. And then what happens is you will draw the other line, somewhere like this, and then you will happen that is you will just kind of sometimes reflect in this way. As you can see, it will be different shape. So it is good for you to understand first what is somewhat the shape, and then find a point where it passes, and you can have an idea and then just reflect to find the other answer. So that is the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching, and I will see you soon.